So problem 4.27, number 1, our given is x squared minus 3x with interval 0, 4. So for this problem, we're going to be using the average value theorem and the antiderivative equation. Just like 4.25, the average value theorem is very similar to the mean value theorem. The only difference is instead of having f into cb minus a over here, we now have 1 divided by b minus a in front, and that's about the only difference with the mean value theorem and the average value theorem. So my first step is I input our givens into our equation, and so that gives me g of x equals 1 divided by 4 minus 0. Our b is 4 and our a is 0, and then integral 4 between 0 parentheses x squared minus 3x. So our next step is going to be just like we did in 4.25, how the integral 4 between 0 applies to the x squared and the negative 3x. We're going to apply the integral to them separately, so then we could apply the antiderivative equation, which is easier when they're alone and separate. So we then get down to g of x equals 1 over 4 integral x squared minus 3 parentheses x, and like I did before in 4.25, I'm kind of limited on steps right here because my whiteboard is not as big. But like I did in 4.25 is I moved the constant over just so it's easier to input our values into the antiderivative equation, and since x squared has a 1 in front of it, there's an invisible 1 in front of the, between the 1 over 4 and the integral 4 between 0 right here, and then this negative 3 just gets moved over in front of the integral right here to negative 3 integral 4 between 0 parentheses x. And then our next step is to input the x squared and the x into our antiderivative equation, resulting in g of x equals 1 divided by 4 integral 4 between 0 parentheses x cubed divided by 3 minus 3 integral 4 between 0 parentheses x squared divided by 2. And so that's the result after you get our antiderivative, or after inputting our values into our antiderivative equation. Then we now redistribute that integral 4 between 0 back to the entire problem, and we then conjoin the two new x values that we got together as 1. So we end up getting g of x equals 1 divided by 4 integral 4 between 0 brackets, because it applies to all of them, the two new inputs we just got, the two new values, x cubed divided by 3 minus 3x squared divided by 2 is our new equation. And so just like we did in 4.25, when we get our new equation, we then input our integral b and a into the equation. So for this we have 4 and 0, so our first step is going to be inputting 4 into all the x's into this equation, and then we're going to be doing the same with 0, and that's what we get here. This is the 0 portion and this is the 4 portion. Just doing algebra, 4 times 4 times 4, 64 divided by 3 minus 24 divided by 2. So then you get a g of x equals 1 divided by 4 brackets 28 over 3. Oh my gosh. Minus 0 because the 0, our a term is 0, and so anything multiplied by 0 is 0. So we end up getting g of x equals 1 divided by 4 brackets 28 divided by 3, which is right here, and then we're going to bring that up top over here and finalize it. We're just solving for g of x at this point to see if our average point fits within the interval. So g of x equals 28 divided by 12. G of x equals 2.333. Infinite keeps going, and then 2.33 is in between our points 0, 4, and so it does work. And we use the average value theorem instead of the mean value theorem, and the ultimate difference is that we're just checking the validity of all these points rather than just one single point, which is what we do with the mean value theorem. And we also use the antiderivative equation again. We use the antiderivative equation in the average value theorem and the mean value theorem. And this is number 1.